Welcome, curious minds, to the deep dive. Today, we're not just scratching the surface of reality. No, we're taking a really mind-bending journey into a theory that might just, redefine everything you thought you knew about the universe.
Right.
Forget the familiar building blocks, the particles and forces, the gravity pulling us down, the matter we touch. What if all of it, every star, every atom, maybe even every thought, wasn't quite what it seemed? What if it's more like an intricate, emergent dance, or something far more fundamental? Get ready, because we're about to explore a universe built not on static things, but on an idea, really, a principle of interconnected harmony.
That's exactly it. The deep dive today is into a truly groundbreaking theoretical framework, the unified coherence theory of everything.
Okay.
And our mission really is to unravel how this theory proposes that coherence. If you can think of it as the underlying harmony, maybe the structured flow, or even the intrinsic tune of existence is the very bedrock of reality.
Bedrock. Wow.
Yeah. And from this foundational coherence, all known physics, all particles, all forces, even the very fabric of space-time itself just sort of gracefully emerges.
And when we say groundbreaking, we absolutely mean it. Our sources for this deep dive are, well, they're a series of detailed academic papers and their appendices.
Very detailed.
Yeah, and they don't just tweak existing physics. They fundamentally redefine core concepts from the ground up. You're going to find some serious aha moments in this deep dive, I think.
Oh, definitely.
Those flashes of insight where complex ideas suddenly click into place and, surprising connections you might never have anticipated just reveal themselves.
It's quite elegant when it clicks.
Exactly.
Yeah.
This isn't just about adding a new chapter to the physics textbook. It feels more like tearing out the old chapters and starting a new, unified story. It's a radical shift in perspective, moving away from discrete, separate particles and isolated forces
Towards a truly unified, interconnected reality where everything is interwoven by this profound concept of coherence. It's a big picture shift.
A very big picture. Okay, let's get into it. So let's begin our journey with something that probably sounds familiar, especially if you've ever touched upon nuclear physics or, even just basic electricity.
Okay.
The classical Coulomb barrier.
Right, the standard repulsion.
Exactly. We typically understand it as electromagnetic repulsion, right? The invisible force that prevents positively charged atomic nuclei from just smashing together and fusing. It's a fundamental force, a classic example of charges repelling each other. Simple, right? Seems so straightforward, just a basic law of nature.
It is simple in its common understanding, yes, but maybe not as fundamental or as purely electromagnetic as we've always thought. This unified coherence theory presents a really radical reinterpretation.
Okay, how so?
It suggests that the Coulomb barrier isn't purely electromagnetic in its essence. Instead, it's actually a coherence gradient discontinuity.
Oh, okay. Coherence gradient discontinuity. That's a mouthful. Let's unpack that.
Yeah, let's do that. So this theory posits that it's a universal principle, a kind of inherent incompatibility that arises whenever two distinct structured fields or systems try to integrate, try to come together.
So not just particles.
Not just particles at all. And to give you a feel for what a coherence gradient means, imagine it as the structured flow or maybe the tension field of any organized system. Essentially, how smoothly and directionally ordered a system's internal information or energy is. Think of the disciplined flow of a river versus, say, turbulent water.
Okay, I think I'm getting it. So if a gradient is like that structured flow, then a discontinuity in that gradient means an abrupt change. Or, like you said, a fundamental incompatibility between two of these coherent flows or patterns.
Exactly. So when two systems with different incompatible coherent flows try to merge, this barrier just naturally pops up.
And the core features here are really insightful, right? Because they seem to go way beyond just atomic nuclei. The theory suggests that if these coherence gradients are compatible, like two perfectly tuned musical notes blending, right, seamlessly,
then the barrier minimizes or maybe even vanishes, allowing for easy connection or integration. But here's the rub. If the gradients are incompatible, like trying to force two misaligned gears to mesh, maybe, or two clashing musical chords.
Perfect analogy.
Then the barrier manifests strongly, actively resisting any integration or fusion. It basically preserves the distinctness of each system. It keeps them separate.
Exactly. And what's truly profound, I think, and really elegant about this reinterpretation is its universality. The theory proposes that wherever self-organization exists, the maintenance of individuality is mediated by Coulomb-like coherence barriers.
Wow. So this isn't just about atomic nuclei anymore. It's like a blueprint for any system that wants to maintain its identity when it meets another one.
Precisely. Think about it. A cell, an organism, even something like a society or a culture. And in a beautiful reversal of how we usually think about it, overcoming a Coulomb barrier, whether that's achieving nuclear fusion in a star or maybe bringing two conflicting ideas together in a conversation.
Yeah. It isn't just about applying immense external energy to force things together. Fundamentally, it requires coherence restoration or gradient bridging.
So you're saying the energy you use isn't just brute force, it's the energy needed to align these underlying coherence gradients, to bring their tunes into harmony.
That's the core idea. You need to harmonize the flows. If you fail to achieve that alignment, well, separation and distinctness just persist. The barrier holds.
And this is where the theory truly goes beyond physics and becomes incredibly intriguing, maybe even a little mind-bending for us as listeners.
Yeah.
Because this concept of a generalized Coulomb barrier, this idea of incompatible coherence gradients, it isn't confined to subatomic particles at all, is it?
Not in the slightest. The source material provides some really surprising concrete examples that bring this abstract concept right into our everyday lives, makes it very relatable, and shows its universal reach.
Okay, give us some examples.
Well, let's take something we all understand or at least experience. Human relationships. You know, that feeling of social repulsion. That sometimes inexplicable inability to truly connect with someone. Where you just don't click.
Yeah, absolutely. We've all been there.
This theory interprets that not just as, say, a personality clash, but as a discontinuity in mental emotional resonance gradients. It's like a mismatch in the coherent flow of your inner worlds. Your fundamental tunes just aren't harmonizing.
A mismatch in resonance gradients. Interesting. Okay, what else?
Or consider something as fundamental as language and meaning. We've all experienced miscommunication, right? That moment where you feel like you're speaking entirely different languages, even though you're using the same word.
Oh, definitely. Frustrating.
The theory explains that frustration as a semantic coherence gradient mismatch. The organized flow of meaning and intent in one person's mind just isn't aligning or resonating properly with the others. It's like two people trying to read from completely different musical scores but expecting to play the same melody.
That's a great way to put it. And the examples go further, don't they? Into biology.
They do. Think about cells and their membranes. We know cell membranes are selectively permeable, meticulously regulating what goes in and out, right? Maintaining the cell's internal environment.
Sure. Basic biology.
This theory reinterprets that selective permeability as biological coherence gradients regulating inside versus outside. The cell actively maintains its internal coherence and identity by essentially creating a barrier against incoherent or incompatible external elements. It's not just a physical filter, it's a coherence-based boundary.
A coherence boundary.
Yeah.
Okay. And even bigger scales, like geography.
Absolutely. On a much larger scale, consider things like borders and geography, rivers, mountain ranges, or even national boundaries. They aren't just physical divisions. They can be seen as material or cultural gradient discontinuities, where different organized systems, ecological, social, political, meet and maintain their distinctness. They often resist full integration without some profound bridging of their underlying coherence.
Huh. So even a river could be a coherence discontinuity.
In a sense, yes. And zooming out to the grandest scale imaginable, even the vast gravitational voids and walls we observe in the large-scale structure of the universe, these are described as coherence density discontinuities at cosmic scales.
So they aren't just empty space.
Not merely empty. They represent regions where the cosmic coherence field itself is structured differently, creating boundaries between large cosmic structures. What's truly profound about all these examples, though, is that this isn't just meant as an analogy or a metaphor.
Right.
The theory posits that the generalized Coulomb barrier is a genuine, universal organizing principle. It describes the fundamental mechanism by which distinct, self-organizing systems, from the subatomic to the cosmic, maintain their individuality across all scales and domains of existence. They do it by resisting incompatible coherence flows, essentially defining their identity through their internal coherence. Hashtag fermions and the internal coherence barrier, Pauli exclusion reinterpreted.
Okay, let's dive back into the quantum world then, because this is fascinating. Specifically, let's talk about the Pauli exclusion principle. For fermions, the particles that make up matter, like electrons, quarks, this principle says no two identical fermions can occupy the same quantum state at the same time.
A cornerstone of matter, absolutely.
It really is. It explains everything from why atoms are stable to how electrons arrange themselves in shells. But how does this seemingly unbreakable rule fit into a coherence framework? How can something so fundamental be, well, reinterpreted?
This is another place where the unified coherence theory offers a really powerful reinterpretation, revealing what it claims is a deeper layer of reality. The Pauli exclusion principle within this framework arises from what's termed a fermionic coherence barrier, or FCB for short.
Okay, FCB. So it's not the usual electromagnetic repulsion.
No, it's fundamentally different. It's not due to a classical force like charged particles pushing each other away. Instead, it's described as a spin-induced phase misalignment.
Spin-induced phase misalignment. What does that mean?
Imagine the internal coherence field of a fermion, its unique tune or pattern. This theory suggests it has a kind of internal twist or deformation linked to its spin. When another identical fermion comes close, this inherent twisting creates a kind of repulsion-like energy cost due to what the theory calls internal coherence field torsion.
Torsion, like a twisting force.
Ah, yeah. Essentially, fermions inherently possess an internal coherence phase gradient that resists fusion or overlap with another identical fermion. It's like trying to fit two identical spiraling screws into the same exact hole at the same time. Their internal twist, their inherent structure, prevents them from occupying the same space and state.
Okay, hang on. Here's where it gets really interesting because this completely flips our usual understanding, doesn't it? So the familiar charge repulsion, what we normally think of as the electromagnetic Coulomb barrier between two electrons, for instance, that's actually a secondary effect.
That's exactly what the theory proposes.
Wow. So the primary reason they repel, the fundamental exclusion, isn't their charge. It's this more fundamental coherence phase misalignment deep inside the particle itself.
Precisely. That's the massive conceptual shift.
Yeah.
It implies that this deep-seated property of fermions isn't primarily electromagnetic, but rather topological, rooted in the structure of their internal coherence fields. It's like an intrinsic no-go zone built into their very nature.
That's huge. Okay, so can you compare the two barriers side by side for us, the fermionic one and the classical one?
Absolutely. Let's contrast them clearly to really make it quick. For the FCB, the fermionic coherence barrier, its origin is this spin phase coherence discontinuity. Its mathematical operator, what enforces it, is the antisymmetric wave function constraint you learn about in quantum mechanics. And the barrier type itself is fundamentally one of coherence incompatibility, an intrinsic inability for these identical coherent structures to merge smoothly.
Okay, that's the FCB, now the classical one.
Right. In sharp contrast, the classical Coulomb barrier, as we usually teach it, originates from an electromagnetic field discontinuity. It operates via an inverse square repulsive force, getting weaker with distance. And fundamentally, it's a force-mediated repulsion. It's about fields pushing things apart.
Got it. Force versus incompatibility.
Exactly. And the theory gets more specific. It states that for any two identical fermions, their internal coherence phase fields, let's call them 1x and 2x, must inherently differ by an odd multiple of x. So the ecdiacs lineups 4n plus 1. This mathematically enforces incoherence if they try to occupy the same point.
So even without charge, they'd still repel.
They'd still face this phase gradient-induced energy barrier, yes. A true internal resistance to overlap. The resulting FCB energy density, the strength of this barrier, is directly proportional to the square of the difference in their coherence gradients. EFCBX is proportional to Coulomb x 2x squared, and this energy actually diverges, becomes infinite, as identical fermions try to occupy the exact same spatial point.
Infinite energy. No wonder they don't overlap.
Precisely. This distinction leads to a really profound conceptual difference between particle types. The theory posits that fermions are coherence defect particles. Their internal coherence field tensor, key, is non-zero. It represents an inherent torsion, a twist, a discontinuity in the underlying coherence fabric. Think of them as localized knots or twists.
Okay, like little glitches in the matrix.
Kind of, yeah. On the other hand, bosons are coherent smooth particles. They are characterized by coherence phase alignment. Their key is approximately 0. Their internal fields are smooth, harmonious, without those intrinsic twists.
Which is why they can occupy the same state, like photons in a laser.
Exactly. This allows them to bunch together. And this reinterpretation isn't just philosophical talk. It's mathematically rigorous. It leads to coherence-structured generalizations of fundamental equations like the Pauli and Dirac equations. In these modified equations, these coherence phase gradients directly contribute to the quantum dynamics. They effectively behave like an internal U1 gauge field influencing the particle's motion. It's a much deeper, more unified explanation for why matter is structured the way it is.
Okay, this is really building towards something big.
Right.
This brings us to the grand proposal, right? The absolute cornerstone, the heart of this unified coherence theory. A universal coherence field, X.
Yes. The fundamental entity.
It's presented as the fundamental entity, the actual fabric of reality itself. But what is it at its core? How can one single field be the source of literally everything we experience? It sounds almost too grand to wrap your head around.
That's a great question, and it's where the theory truly shows its ambition. X is defined as a real scalar field. That means it has a single value at every single point in space-time.
Okay, a number everywhere.
Right. And that number represents the total coherent phase structure of the universe at that specific location. Think of it like a continuous, invisible ocean of cosmic harmony, maybe? A vast, interconnected medium that underpins everything.
So it's not just a background.
Definitely not just a background. It is the primary object. It encodes the local coherence properties of the entire cosmos. And the theory claims its gradients, those structured flows we talked about, and its curvature, the localized deformations or bends within this field, are what yield all known forces, particle structures, and the emergence of space-time itself. The beauty of it, according to the theory, is that this field is smooth almost everywhere, but it has specific topological defect sites.
And those are?
Those are the particles we observe.
Okay, so this implies that particles like electrons or quarks, they aren't arbitrary isolated point things, or even just excitations of all the different fields we talk about in the Standard Model. Instead, they're conceptualized as localized, quantized coherence fluctuation packets of this single overarching universal field, like ripples on this cosmic ocean of coherence.
Precisely. Your ripple analogy is perfect. Think of it this way. The ground state of this field, let's call it HA, represents a state of maximum perfect coherence, like a completely calm, unperturbed ocean surface, an unbroken symmetry.
Okay, perfect harmony.
Right. Now, fluctuations around this state, which we can denote as ants, represent localized modulations or disturbances in this otherwise smooth coherence. Ripples on the surface.
Got it.
And the theory states that small excitations of X behave exactly like quantized scalar fields, much like, say, the hypothetical Higgs boson in the Standard Model. But what's really powerful here is that their mass isn't just some arbitrary value plugged in.
No. How does it arise?
It's derived directly from the coherence potential itself. That mass, IPAS, is equivalent to the second derivative of the coherence potential evaluated at the ground state.
Okay,
right?
That's mathematically neat.
It is, and it means that fundamental quantum equations, like the Klein-Gordon equation, which describes spinless particles, naturally emerge from the dynamics of this universal coherence field. They don't need to be assumed separately. The coherence field isn't just a medium, it's the actual source of mass, quantum behavior, and the very existence of particles. #tag mapping forces as coherence dynamics.
All right, so if everything, particles included, comes from this one fundamental field,
Right.
X, then how do the familiar fundamental forces, gravity, electromagnetism, strong, weak, how do they actually manifest? What's their role here? Because our current picture has them as distinct interactions, mediated by different particles.
Right, the Standard Model view. But what's truly fascinating here, and really a core tenet of this coherence theory, is that it posits forces are not fundamental interactions between particles in that traditional sense. They're not mediated by separate force-carrying bosons being exchanged back and forth.
Okay, so what are they then?
Instead, they are manifestations of curvature, tension, and phase structures within the universal coherence field. It's a completely different way of thinking about how interactions happen. It's not about particles throwing other particles at each other. It's about how the underlying coherence field itself is behaving, how it's structured.
So the field itself is the interaction, in a way.
In a very real way, yes.
Okay.
Let's break down how each force emerges. Think of them like different facets of a single diamond, all derived from the behavior of X.
Okay, let's do it. Gravity first.
Gravity. This theory describes gravity not as a force pulling objects together in the Newtonian sense, or even just warped space-time in the Einsteinian sense, but as the global tension and gradient of the coherence field across space-time.
Global tension, like stretching a sheet.
Exactly like stretching a sheet. Imagine this vast, flexible sheet, our coherence field. When there's a large concentration of coherence, which corresponds to mass or energy, it creates tension and gradients in this sheet, causing it to bend or stretch. This bending and stretching of the coherence field itself is what we perceive as gravity.
The space-time curvature.
Right. The curvature of space-time, which Einstein described with the Riemann curvature tensor, is seen here not as an intrinsic property of empty space itself, but as arising directly from second-order derivatives of x. Specifically, Rieman's is related to terms like Jajic.
Wow. Okay, so massive objects aren't just warping space-time. They're locally intensifying and bending the actual universal coherence field.
That's the idea. Now, electromagnetism.
Okay, charges and fields.
This force is explained as local phase circulation defects and tension around coherence vortices. Think of water flowing smoothly, right? And then imagine a whirlpool or an eddy forming within that flow.
Okay, a vortex.
Right. In this theory, electromagnetic fields and charges are seen as specific types of these local vortices or circulation defects within the coherence field. The electromagnetic field tensor, phi, which describes electric and magnetic fields, is seen as a local U1 level manifestation, kind of embedded within the larger, more fundamental coherence field tensor.
So charge is like a persistent swirl in the coherence field.
Essentially, yes. Electrical charge and electromagnetic fields are a topological winding, a specific type of phase defect within the coherence field, like a continuous current or twist in its flow.
Right. What about the strong force holding nuclei together?
The strong force is characterized as high torsion compression zones in coherence curvature. Imagine taking a piece of fabric, like that sheet again, and twisting and compressing it incredibly tightly to create a dense, highly energetic knot.
Okay, a really tight knot.
That's akin to the strong force. It's responsible for forming what the theory calls bound coherence networks, like quarks and gluons inside protons and neutrons. These are seen as tightly interwoven high-energy coherence binding modes. It involves what the theory calls triplet coherence winding, or SU3-like structures, suggesting a complex, non-abelian twisting and braiding of the coherence field that holds these fundamental particles together with immense strength.
Braiding. Okay. That leaves the weak force. Radioactive decay, particle changes.
Right. The weak force, responsible for those processes that convert one type of particle into another, is understood here as coherence, phase tunneling, and reconfiguration processes.
Tunneling, like quantum tunneling.
Kind of analogous, yeah. Think of it like the coherence field momentarily tunneling through an energy barrier or perhaps reconfiguring itself from one stable phase state, one pattern to another. This allows for phase shifts or flavor changes in particles like a neutron changing into a proton. It's the mechanism by which the coherence field can subtly transform or mutate its local configurations.
This sounds like, well, like the ultimate unified field theory. The dream of physics, right?
Yeah.
How does this theory actually formalize the unification of all these forces if they're all just different aspects of X? That's the big question.
It is the big question, and it does so by introducing the Coherence Unification Group, or CUG. It describes this as a hypersymmetry group.
Hypersymmetry. What does hyper mean here? Is that different from usual symmetry groups?
Yes, crucially different. Its proposed structure is something like GCUG is approximately hyper U1 times hyper SU times hyper SU3. Now, that hyper prefix is absolutely key. It signifies that these are not your conventional gauge groups like in the standard model.
Okay.
Instead, they are deeper, more fundamental coherence symmetry groups that are proposed to arise directly from the fundamental field tension and curvature dynamics of X.
So they're built into the coherence field itself.
Exactly. And the profound implication is that all forces emerge as broken modes of the hypercoherence group under coherence reduction.
Broken modes, like symmetry breaking.
Precisely. Picture a coherent symmetry breaking chain, analogous to how water freezes from a single liquid state into different forms of ice depending on conditions. At a hypothetical primordial state of full coherence, maybe in the very early universe where everything is maximally unified, there's a single unified GCUG symmetry.
One unified force.
Right. Then, as the universe's overall coherence density reduces perhaps as it expands and cools down, spontaneous coherence symmetry breaking occurs. This breaking causes the single GCUG to split into distinct manifestations. Gravity separates out, plus a combined strong and electroweak force.
Okay, first split.
Then, as coherence reduces further, the electroweak force, which we know from the standard model, splits again into electromagnetism and the weak force.
Wow, so it's a cascade.
It's a beautiful, hierarchical unfolding of reality from a single, unified source of coherence. It offers an explanation for how the universe we observe, with its distinct forces and particles, could arise naturally from a perfectly harmonious origin.
All right, so if particles and forces are all these complex manifestations of this universal coherence field, what about the basic properties that define particles? You know, mass, spin, charge. We traditionally rely on things like the Higgs field to explain mass, for instance.
Right, the Higgs mechanism.
How do these fundamental properties arise in this coherence framework? It really feels like we're stripping everything down to the studs and building it back up from just coherence.
That's a very apt way to put it, and this raises an important question naturally. It's another area where the unified coherence theory offers a truly unique and I think elegant perspective. So mass. In this theory, mass arises from stored coherence tension around a coherence defect.
Stored coherence tension. So
Sure.
it's not about interacting with an ambient Higgs field,
Right.
like wading through molasses.
No, not directly like that. It's more about the localized deformation, the internal strain, or the stress within the coherence field itself where the particle exists. So, to put it simply, mass is simply localized coherence field stress.
Like a knot causing tension in a rope.
Exactly. It represents a potential energy density intrinsically associated with these localized deformations, like a tightly wound spring or a stretched rubber band that stores energy within its structure.
Okay, so mass is stored energy, but specifically stored coherence tension energy.
Precisely. And what's even more remarkable is how this theory explains mass quantization, why particles have specific discrete mass values. The mass of a particle isn't random, it's quantized according to the total integrated coherence field gradient around the particle.
Integrated gradient, like how much twist or tension is packed into that localized defect.
You've got it. Think of it as different particles having different coherence tension winding numbers, which directly dictates their observable mass.
Ah, so that could explain the huge differences in mass we see, like between an electron and a top quark.
Exactly. It provides a potential mechanism for the mass hierarchies. Light particles, like neutrinos or electrons, are proposed to possess small coherence gradient energy. Their coherence fields are less intensely deformed or twisted, meaning less stored tension, hence less mass.
In stark contrast, heavy particles, like the top quark, exhibit large coherence gradient and intense local tension. This indicates a much more significant and localized deformation, a far more tightly wound spring in the coherence field, storing much more tension energy, hence having much greater mass.
And mathematically, how does that connect to eMMCS?
Mathematically, the mass energy of a particle, MCS, is directly proportional to the integral of the local coherence tension energy density over the volume of the defect. This energy density, in turn, is proportional to the square of the coherence field gradient, something like attention x, where is some energy scale. So mass is directly a measure of the localized energy stored in the coherence field's gradients, a direct manifestation of its internal stress. Hashtag check spin and charge from coherence topology. Okay, mass is coherence tension. What about spin and charge? These inherent, almost mystical properties that really define what a particle is. They seem so fundamental to a particle's identity. How do they, too, emerge from this single, all-encompassing coherence field? It almost sounds like the universe is, I don't know, knitting particles from pure pattern.
Your intuition about knitting particles from pure pattern is surprisingly close. They emerge topologically from the universal coherence field.
Topologically, what does that mean here? Like geometry?
It's related to geometry, but it's about properties that remain unchanged even if you continuously deform something. Like how a donut and a coffee cup are topologically the same because they both have one hole. It's about fundamental structure.
Okay, so how does that give us spin?
Spin is described as coherence vorticity. You can visualize it as the winding, the swirling, or the twisting of the coherence field X around a point or a region in spacetime.
Like a little whirlpool.
Exactly. The theory states that fermionic spin, kind electrons and quarks have, emerges from half-winding structures, specifically from something called bivector coherence reductions. Imagine taking a strip of paper, giving it a single half twist, and then joining the ends to make a Mobius strip. That half twist is fundamental. That's the kind of topological structure associated with fermions.
On the Mobius strip, okay. And bosons?
Meanwhile, bosonic spin 1 and spin 2, like photons or gravitons, might have arisen from simpler integer winding structures, like a full twist or no twist at all. So the spin of a particle is a direct result of how its associated coherence field is topologically twisted or knotted.
So if you went around a fermion,
Quantitatively, if you traced a closed loop around a fermionic spin defect in the coherence field, the phase of the coherence field would change by, or 180 degrees, a half winding. For a boson, it would change by 2 Marn 360 degrees, or 0.
fascinating. Okay, what about charge? Electric charge.
Charge is explained as phase circulation around defects in X. Imagine a continuous current, a kind of flow, within the coherence field that circulates persistently around a localized disruption or hole in the field.
like water swirling down a drain.
That's a decent visual, yes. And charge quantization, the fact that charge comes in discrete units, like the electron charge, arises because the coherence field X must return to itself up to 2n after one complete circulation around the defect.
What does that mean, return to itself?
It's a fundamental topological constraint. Just like if you walk all the way around a flagpole, you have to end up facing the same direction again. Similarly, the coherence field's phase must return to its original value after a full loop, but it can do so after completing a full cycle, or 2 cycles, 4, and so on, multiples of 2, denoted by n.
Okay. So the amount of winding determines the charge.
Exactly. Whether it's an elementary charge, like +1 or -1 for electrons, protons, or a fractional one, like quarks, it relates directly to how many times the coherence phase field wraps around that topological defect, like the number of turns in a coil dictating magnetic field strength.
So what does this all mean for our understanding of matter? It sounds like we're not just looking at a collection of fundamental particles anymore, but more like a dynamic topological landscape.
That's a perfect way to describe it. This allows for what the theory calls a coherence standard model, where particles are topological defects or structured coherence field configurations, quantized according to their coherence phase topology.
A coherent standard model. Can you give specific examples? Map some familiar particles.
Sure, this framework transforms the particle zoo, as it's sometimes called, into a structured catalog of coherence defects and topological windings. For instance, the electron is described as a combination of single-phase circulation plus half vorticity. This configuration naturally gives it an electric charge corresponding to 1 unit and a spin of half. It's a very specific kind of twist and flow pattern in the coherence field.
Okay, charge 1, spin half.
Got it. A photon, the particle of light, is seen as a full-phase circulation with no mass. This is entirely consistent with its known properties. Charge 0 and spin 1. It's like a smooth, propagating wave of coherence without a localized twist defect.
Makes sense.
Quarks are more complex, as you'd expect. They exhibit fractional phase circulation plus braided color vorticity. This structure elegantly explains both their fractional electric charge, like plus CO3 or NaCS13, and the enigmatic color charge from quantum chromodynamics. Imagine a multi-stranded braid where each strand represents a different color aspect, a very intricate topological configuration.
Braided color vorticity.
Wow. The Higgs boson, which in the standard model gives mass to other particles via interaction, is interpreted here somewhat differently. It's seen as a scalar coherence field condensation. It has no spin itself and generates mass through its local field deformation, essentially. It's a direct manifestation of the coherence field's inherent potential landscape. A sort of lump or variation in the field that creates mass through its presence, affecting the tension around other defects.
So it's part of the coherence field's own structure.
Yes. And finally, color charge itself, the source of the strong force in QCD, is seen as triplet coherence winding, a non-abelian phase circulation. This implies a more complex, interwoven topological structure within the coherence field, where the color isn't just a label, but reflects a specific type of braided coherence pattern. This framework is truly remarkable because it aims to describe the entire particle landscape as emerging purely from the topology and dynamics of the underlying coherence.
Okay, this theory keeps getting bolder. This next claim is arguably one of its most radical around, that space-time itself, space and time, is not a fundamental pre-existing background where physics happens. Like a static stage for cosmic events.
Right, not the container, but part of the content.
Instead, it posits that space-time is emergent. This is such a huge departure from Newton, where space is absolute, and even from Einstein, where space-time is dynamic but still a given manifold.
Yeah, absolutely. A fundamental departure.
How on earth can space, and even dimensions themselves, emerge from a coherence field? It almost feels like pulling a cosmic rabbit out of a hat.
It certainly feels that way initially. It's one of the most profound aspects of the unified coherence theory, and it really forces us to rethink what fundamental truly means. It introduces this concept of hyperfractal structuring.
Hyperfractal structure.
Yeah. The theory posits that coherence gradients within X, the universal field, don't simply unfold linearly or uniformly, like lines on a perfect grid. Instead, they exhibit a deeply self-similar, nested, and direction-dependent organization. Think of a natural fractal like a snowflake or the branching pattern of a tree.
Right, patterns within patterns.
Exactly. The intricate repeating patterns define its very form. In this theory, this self-structuring process, where coherence gradients build these nested layers of relational flow across scales and directions, that process is what gives rise to the structure we perceive as space.
So the structure is space.
The direct and breathtaking claim is space is not pre-existing. It is emergent from hyperfractal coherence structuring. It's a dynamic, actively creating medium, not just a passive static container.
Wow. Okay. And dimensions, too. 3 space, 1 time. Are those emergent?
That's the claim. The theory suggests that dimensions themselves are also emergent, not fixed constants of nature. They arise from the degrees of freedom in coherence phase structuring. Think of it this way. At higher coherence densities, maybe like in the extreme conditions of the very early universe, the theory suggests that more relational dimensions can unfold.
More than 3 space dimensions.
Potentially, yes, leading to what it calls higher dimensional structures. Conversely, at lower coherence densities, like in our current relatively cold and sparse universe, dimensionality appears frozen into our familiar 3+1 structure of space and time.
So dimensionality could be dynamic.
Dynamic, fractal, and not a fundamental background constant, according to this view. And this ties back to the field itself. The coherence field is actually proposed to be a function of both position x and the local coherence flow vectors, x dot dot. So x dot section.
What does the x dot mean?
It represents the direction and speed of the coherence flow at that point. This explicitly shows that the coherence field itself depends not just on where you are, but on the direction and flow of coherence at that point. This reinforces its inherently dynamic and direction-dependent nature.
And this emergent, direction-dependent nature of space that leads us to Finsler space, right? What exactly is Finsler space, and why is it crucial for describing this emergent space-time? I'm guessing it's not the flat paper geometry we learned in school.
You're absolutely right. It's a significant departure from standard Euclidean or even the Riemannian geometry that Einstein used for general relativity. Finsler space is a generalization of Riemannian geometry.
How is it generalized?
Well, in standard Riemannian geometry, the distance between 2 points depends only on their coordinates, only on where they are. It's like measuring distance on a fixed, unchanging map. But in Finsler space, the distance between 2 points depends not only on their coordinates, but also on the direction of the connecting path.
Direction matters for distance.
Yes. In the context of this theory, that direction is the coherence flow vector, Stark. This means the metric, the mathematical tool that defines distances and geometry, depends on both position and the direction of flow. Mathematically, the infinitesimal interval, the little bit of distance, is ds story s equals tx x6. That x dot in the metric explicitly indicates dependence on direction or flow.
Can you give an analogy?
Sure. Think of it like this. In a conventional space, maybe walking 100 meters east takes the same effort or covers the same fundamental distance as walking 100 meters west. But in a Finsler space, imagine walking into a strong wind. Walking 100 meters into that wind might be very different, might represent a different Finsler distance compared to walking 100 meters with the wind at your back, even if the coordinate distance is the same. The cost, or the fundamental interval, is direction dependent.
So if I'm understanding this right, the very fabric of reality, how we measure distance, how we perceive geometry, maybe even the flow of time, is coherence flow dependent. It's relational, not absolute. It's not a static grid that things just happen on, but a dynamic, interwoven medium that's itself shaped by these underlying coherence flows.
That's precisely what the theory confirms. It's a truly breathtaking realization, if correct.
Yeah.
It states explicitly that space-time curvature, gravity, is not a property of empty space. This is a key and profound departure from Einstein's general relativity, where space-time itself is the thing that curves.
So what causes curvature then?
Instead, curvature is the result of coherence structuring dynamics at the hyperfractal level. It fundamentally replaces Einstein's assumption of a pre-existing manifold that just gets warped by mass and energy. So gravity isn't just a force warping a pre-existing space, it's the large-scale consequence of these intricate coherence gradients bending and stretching the very medium of reality itself. And so Finsler space is the relational medium where coherence structuring projects interaction. It is the wave medium of relational oscillations, meaning it's the actual substance or canvas upon which the wave functions and particles we observe play out their existence. The theory even proposes a coherence curvature tensor, RENA X, that directly reflects this dependence on both position and coherence flow, showing how spacetime's curvature emerges directly from the coherence field dynamics at this hyperfractal level. It's a universe where geometry itself isn't fixed, but is a fluid, emergent dance of coherence.
Okay, this next part is arguably the deepest, maybe the most profoundly insightful, and frankly, the most revolutionary aspect of this whole unified coherence theory. Traditionally, we treat Newton's the law of force, mass, acceleration, and Einstein's EMC mass-energy equivalence as distinct laws, right? Related, sure,
Yeah.
but describing separate domains, mechanics and relativity.
Yes, usually taught quite separately.
How, then, does this theory manage to unify them? What's the secret sauce? How does it bring these two giants of physics, Newton and Einstein, under one single coherent roof? It seems almost impossible.
The secret, if you can call such an elegant insight a secret, is what the theory terms the unified coherence force-energy principle. This principle states something really remarkable. Both force and energy emerge as distinct projections of an underlying coherence field tension condensate.
Okay, wait. Distinct projections of an underlying coherence field tension condensate. Let's break that down.
Right. This is a truly unique contribution, offering a singular origin for what we previously thought of as two separate fundamental concepts, force and energy. The theory is saying there aren't actually separate phenomena of force and energy at the deepest level. Instead, they are complementary manifestations, like two different views, of the same underlying coherence tension structure. Think of a tightly wound spring again. You can talk about the potential energy stored in it, or you can talk about the force it exerts when released.
Two sides of the same coin.
Exactly. Two sides of the coherence tension coin. Let's really break down the coherence interpretation of each component step by step to grasp this unification. Mass. First, let's reiterate that mass represents localized coherence tension storage. It's not just quantity of stuff or resistance to acceleration, it's a tangible coherence tension condensate. The source material uses a powerful analogy. Think of mass as a coherence field battery.
A battery.
It's a localized region where a huge amount of coherence potential or internal tension is stored, just like chemical energy is stored in a battery ready to be released.
Right. Mass is the battery holding the potential. What about EMC poor?
Energy. EMC4.
Yeah.
This iconic equation, in this view, expresses the total latent coherence potential spread across all possible relational directions inherently stored within that mass, within that coherence battery. It's the full latent gradient field stored within the mass condensate. Imagine the battery fully charged, holding all its potential energy, but not yet connected to anything. It has the potential to deliver energy in any direction.
And the C part, speed of light squared.
The C part term is reinterpreted here as the total latent universal vector field potential. It essentially represents the sum total of the magnitude of all possible directional relational flows that the coherence field can manifest. So energy is the scalar totality of all that potential coherence tension stored isotropically, waiting to be unleashed in any specific direction.
Isotropically means equally in all directions.
Yes, the potential is there, ready to go anywhere. Now, contrast that with force. Force, in this framework, is described as the local vectorial realization of a coherence gradient applied to the condensate. It's directional. Here, the acceleration A is seen not just as a change in velocity, but fundamentally as a local vectorial coherence gradient. Its magnitude is related to the localized coherence phase gradient, perhaps local x.
Okay.
So force F is not just an abstract push or pull, it's a vector realization, a specific directional extraction of that stored coherence tension from the battery. It's what happens when you finally connect the battery to a specific circuit, and the stored energy flows out in a particular direction doing work.
Okay, let me try to process this. This means that Newtonian force is the decoherent directional extraction of Einsteinian energy.
That's a perfect way to summarize the core insight. Yes.
Wow. That's not just a mind-blowing statement. It suggests a dynamic process, right? A transformation where one manifests as the other. It's like the universe is constantly making choices, crystallizing potential into specific directed action.
It is precisely that. The theory elaborates on what it calls a coherence selection event, which is absolutely central to this unification. Think of it as a moment of dynamic choice or manifestation within the coherence field itself.
A coherent selection event. Yeah.
Okay, it happens. Let's look at it in 3 stages before selection. The mass, acting as that coherence tension condensate or battery, inherently stores its latent tension across all possible relational vector modes simultaneously. It exists as an isotropic potential, equal potential in all directions, a full sphere of possibilities, if you will. There's an infinite number of ways its stored energy could manifest.
Okay, pure potential.
During selection, this is the critical moment, a specific coherence directional gradient is chosen or realized. This isn't some random choice. It's triggered by an interaction, an accelerated relational action that leads to an anisotropic, meaning directional realization. This dynamic process is the coherence selection event. It's like the universe deciding which path the energy release will take, which specific flow it will manifest as. It's the moment the battery gets connected to a specific device and the energy flow is directed.
The potential becomes actual in one direction.
After selection, the mass then undergoes local acceleration, Newton's A, as this coherence directional realization of its stored tension, Einstein's E manifesting as Newton's FMA. The force you observe, the directional push or pull, is the direct result of this selection event, this collapse of a universal isotropic coherence potential into a localized specific vector, a determined action.
So force is just energy choosing a direction.
In a profound sense, yes. And to summarize the truly deep implication here, there are no separate laws, only different relational reductions of coherence tension. This theory reveals that force and energy are unified phenomena within the structure of coherence physics.
That's incredible. It completely distinguishes it from mainstream physics, which treats FMA and EMC as fundamentally independent laws, only loosely connected through ideas like work energy theorems.
Exactly. Here, they're presented as two inseparable sides of the same fundamental coherence coin, intimately linked by the continuous dynamic orchestrations of the coherence field. It aims to be a complete conceptual and mathematical framework bridging classical mechanics, relativity, quantum mechanics, and a deeper coherence ontology, weaving them all into a single elegant tapestry of reality. #tagoutro.
Wow. Okay. What an incredible, truly expansive journey we've taken today on the deep dive. Just incredible. We started with something as seemingly straightforward as the classical Coulomb barrier.
Seemingly straightforward, yeah.
Only to see it beautifully reinterpreted as this universal coherence gradient discontinuity, a fundamental principle governing distinctness and identity across all scales of existence, from the quantum to the cosmic.
It really sets the stage for everything else.
It does. We saw how this principle applies not just to atomic nuclei, but potentially to everything from human relationships and language to cell membranes, maybe even the vast structures of galaxies. From there, we dove back into the quantum realm, seeing the Pauli exclusion principle reimagined.
As the fermionic coherence barrier, the FCB.
Right, born from an intrinsic coherence phase misalignment within particles themselves, not just simple electromagnetic repulsion, a much deeper origin.
A topological origin, fundamentally.
And we soar to the grand unifying proposal, the universal coherence field. This single, fundamental scalar field presented as the wellspring, the source from which literally everything else emerges.
The bedrock, as we said.
We explored how particles aren't rigid point-like objects, but quantized topological defects or dynamic fluctuations, ripples, knots, vortices within this field. Their mass, that inherent property,
stems from localized coherence tension, stored energy.
While their spin and charge are profound expressions of topological windings and phase circulations within this universal field, and maybe most astonishingly, space-time itself.
Not a pre-existing stage.
Not a stage, but an emergent Finslerian dance of hyperfractal coherence structuring, with geometry itself directly dependent on the coherence flow, making the very fabric of reality fluid, responsive, relational.
A dynamic canvas.
And finally, to bring it all home, to tie together centuries of scientific thought, we witnessed this stunning unification of Newton's FMA and Einstein's EMC at sheet. We learned they aren't disparate laws, but rather complementary manifestations, projections, of an underlying coherence field tension condensate.
Mass is the stored coherence potential, the cosmic battery.
Energy is its total latent form, the potential waiting to be unleashed in all directions.
And force as the local directional realization, the decohered extraction of that potential through a coherence selection event.
It's truly a holistic, deeply interwoven vision of the cosmos, isn't it? Where everything is intrinsically connected through coherence.
Indeed. And the philosophical implications of this theory are really immense, extending way beyond just physics equations. It proposes that reality is the dynamic orchestration of coherence tension across relational flows. It's not just another physical theory trying to unify the known forces. It feels more like an attempt at a profound reconciliation of mathematics, physics, and metaphysics into a unified vision,
Yeah.
where the apparent fragmentation and separation we see in our universe gives way to an underlying wholeness, an emergent harmony structured by coherence. It really invites us to see the world, maybe, as a symphony of coherence.
A symphony of coherence. I like that. And as you, our listeners, go about your day, here's a final provocative thought for you to mull over, stemming directly from this deep dive. If our universe's fundamental dynamics involve these coherent selection events, where vast, latent potential crystallizes into realized directional action, where isotropic energy within mass becomes a specific, purposeful force, what might that imply for the choices we make in our own lives? If social repulsion is, at its core, a coherence gradient mismatch, and effective communication requires achieving semantic coherence, then what kind of coherence are you bringing to your personal realities, to your daily interactions, to the potentials you choose to manifest? Are you bridging gaps, or are you reinforcing discontinuities?
A deep question indeed.
It's a lot to think about, we know. But that's the beauty of a deep dive. Thank you so much for joining us on this incredible journey today. We encourage you to continue your own deep dive into these profound and potentially reality-shifting ideas. Until next time.